Okay, from page 319, this is a video on graphing systems of linear inequalities. Graphing linear inequalities was easy, we just finished that, and now we're doing the systems thereof, meaning we have two inequalities and we have to put them both on the graph, and we've got to see where on the graph the solutions lie that satisfy both inequalities. In other words, if we take two inequalities, and let's take 2x minus y is greater than or equal to 4, and let's take x plus y is greater than 2. Well, these two aren't in y-intercept format, so it's a little bit hard to graph. So we're going to change that into y-intercept format. Let's do this one over here, and we have 2x minus y is greater than or equal to 4, and we're going to leave the greater than or equal to as it is, and we're going to just move stuff around. So we're going to move the y over here. 2x is greater than or equal to 4 plus y, and what I did there is I added y to both sides, and that's okay. We can treat it almost like we would if this were an equality and had an equal sign there. The only thing we can't do is multiply one side by a negative number, but don't worry, we're not going to do that just yet. So we treat it like an equal sign, and we're going to get y isolated, so let's move the 4 over here by subtracting 4 from both sides, and we get 2x minus 4 is greater than or equal to y. And with that, we have a slope and we have a y-intercept. Let's do the other one over here. This one's a little bit easier. X plus y is greater than 2, so let's subtract x from both sides, and we can just write that out right now. Y is greater than, well, we're subtracting x, negative x plus 2. And that's the translation of this, just by moving the x to the other side. And we've left the greater than side as it is. So this has a slope of negative 1 and a y-intercept of 2. So let's chart these. The pink has a y-intercept of 2 and a slope of negative 1. So it'll go down and over, down and over, down and over, down and over. So that's my slope of negative 1. And it's a greater than sign. It's not greater than or equal to, so remember we have to use the dashed line because the line itself is not going to be part of the solution set. And we know that y is greater than, therefore y has to be higher than this stuff. It has to be in the upper portion of the line, so it's this stuff here. So not including the line, but the half of the universe, the half plane above the line, the upper half, is the solution set for the pink. And for the blue, we have, well, this is done in a bit of a difficult way. Let's flip this around. You can see that y is less than this stuff, so we can write it like this. Y is less than or equal to 2x minus 4. And I flip that around because it's pointing at the y, and so it's still pointing at the y. So now if I graph this, I have a slope of 2 and a y-intercept of minus 4. 1, 2, 3, 4, and a slope of 2. So up 2 over 1, 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 and we continue, and this is a greater than or equal to, so when y is equal to that stuff, it's part of the solution set, so I can draw a solid line because the line itself is part of that solution. So if I draw that line, and now y is less than or equal to that stuff, so we need the lower half. The lower half of the universe. And I think that you can already see that the solution set is the area in here that is defined by both of them. So in here we have the shaded solution area. It does not include this dashed line itself because this is a greater than relation, but it does include the solid blue and all the shaded stuff in between. And so that is how we graph the solution of a system of linear equalities.